Right now, 22 billion kilometers from where you are sitting, a machine older than the internet is falling through absolute darkness at 38,000 miles an hour, and it is listening to something that should not be there. Somewhere past the edge of the sun's influence, past the last place our star has any say over what happens. A 47-year-old spacecraft with less computing power than the key fob for your car is still transmitting, still sending, still functioning, and what it has been quietly reporting back to a small team of engineers in Pasadena has left some of them unsettled in a way they were not expecting to be. This is Voyager 1, and what it found out there was not supposed to be possible. To understand why this matters, you have to go back to 1977 to a launch pad in Florida, where two identical spacecraft were being prepared for a mission that was, on paper, almost embarrassingly simple. Jupiter, Saturn, some pictures, some measurements, a grand tour of the outer planets, made possible by a rare planetary alignment that would not happen again for another 175 years. Nobody involved in that launch expected the machine to still be working when Ronald Reagan and Margaret Thatcher were both out of office, when the Soviet Union had collapsed and been forgotten by a new generation, when smartphones existed, when the very idea of the internet was decades away from meaning anything to anyone. Voyager 1 was built for a 4-year mission. It has now been operating for over 47 years. Stop and sit with that. A piece of 1970s technology running on 8,000 times less memory than a basic smartphone has outlived the political systems, the engineers, and in some cases, the entire scientific paradigms that were in place when it left Earth. By 1980, Voyager 1 had done its job. It swept past Jupiter, revealing volcanoes on Io that nobody expected to exist. It swept past Saturn, capturing images of rings so structured and strange that they rewrote textbooks. And then, instead of shutting down, instead of going quiet, Mission Control did something almost defiant. They kept it going. They pointed it outward, away from the plane of the planets, and told it to keep driving into territory no human-made object had ever touched. This was the beginning of what NASA would eventually call the Voyager Interstellar mission. Nobody knew in 1980 that this decision would still be paying off dividends nearly half a century later. Nobody knew that this spacecraft would become humanity's furthest outstretched hand, still touching, still feeling its way through the dark, decades after everyone who built it assumed it would be silent. Here's the part nobody is talking about enough. Space, the region between the planets and beyond, is not empty in the way we picture it. It is filled with something called the heliosphere, an enormous bubble of charged particles blown outward by the sun like a slow, invisible wind pushing back against the rest of the galaxy. For most of human history, we had no real data about where that bubble ended. We had models, we had predictions, we had educated guesses built on decades of theoretical physics, but guesses are not data, and in 2012, Voyager 1 gave us the real thing. It crossed the heliopause, the boundary where the sun's influence finally gives out and interstellar space begins. For the first time in the history of our species, an object built by human hands left the neighborhood of our star entirely and entered the vast, cold ocean of matter between stars. And that is where the story should have simply continued as a triumphant footnote in the history of exploration. Except it didn't, because almost immediately, Voyager 1 started reporting something that did not match what anyone predicted. Here's why this should matter to you, even if you have never thought about interstellar space for a single second in your life. The models, built by some of the most capable physicists on Earth, predicted that interstellar space would be relatively sparse, thin, a near vacuum, but a vacuum that thinned out gradually the further Voyager traveled from the sun's boundary. Instead, using its plasma wave instrument, an instrument literally designed to listen to the vibrations of charged particles in space the way a microphone listens to sound, Voyager 1 detected something unexpected. The plasma density out there was not thinning gradually. It was, in places, denser than models had predicted, and it seemed to fluctuate in ways that did not fit cleanly into existing theory. Scientists at the University of Iowa who operate the plasma wave instrument described the data as revealing a persistent, structured hum in interstellar space, a low-frequency oscillation that had never been directly measured before because nothing had ever traveled far enough to measure it. Think about what that actually means. For decades, some of the smartest people on the planet built their understanding of the space between stars on theory alone. And when we finally sent something out there to check, reality did not agree with the theory. That contrast between expectation and reality is the quiet, recurring engine underneath almost everything Voyager 1 has told us since 2012, and it is worth pausing on, because it is not a small discrepancy. It suggests that the boundary between our solar system and the rest of the galaxy is more turbulent, more structured, and more dynamic than anyone assumed. It suggests that interstellar space is not a still, silent void, but something closer to a churning, humming sea with pressure waves rippling through it, some of them triggered by solar activity happening back near Earth, arriving at Voyager's position months or even years later like an aftershock from home. The spacecraft that left our sun's bubble behind is still, in a strange way, feeling the sun's pulse, and that alone should reframe how you picture the emptiness beyond our solar system. It is not empty. It is alive with motion we cannot see or hear ourselves. And the only reason we know that at all is because one small, aging machine happened to be positioned exactly right to listen. It helps here to understand exactly how thin the thread of communication actually is. Voyager 1 talks to Earth through a network of enormous dish antennas called the Deep Space Network, with facilities in California, Spain, and Australia positioned roughly a third of the planet apart, so that as the Earth rotates, at least one dish is always pointed toward the spacecraft. The signal Voyager 1 sends back is almost unimaginably faint by the time it reaches one of those dishes, measured in a unit of power so small that physicists sometimes describe it as weaker than the energy of a snowflake landing on the ground. And yet, using dishes 70 meters across and receivers cooled to nearly absolute zero to reduce interference, engineers on Earth are still able to pull a coherent signal out of that whisper, still able to decode meaning from a transmission that has been thinned across 22 billion kilometers of empty space. It is worth pausing on how fragile that entire chain really is. One misaligned antenna, one overloaded receiver, one software error on either end. Any of these at any point could sever the link permanently, and there would be no way to know from Earth whether the silence meant the spacecraft had finally died or whether it was simply, for the first time in decades, unable to find us. But the plasma hum was not the detail that unsettled engineers the most. That came later, and it came from a much more mundane, much more human place. Not a mystery of physics, but a mystery of machinery, and in some ways, that made it worse. In May of 2022, something started going wrong. Voyager 1's attitude, articulation, and control system, the subsystem responsible for keeping the spacecraft's antenna pointed precisely at Earth across a distance of billions of miles, began sending back telemetry data that made no sense. The numbers looked random, garbled, as if the spacecraft was reporting its own status through a language nobody on Earth could translate anymore. And here is the detail that tends to stick with people. Despite the nonsensical telemetry, the spacecraft was, by every other measure, working fine. Its antenna was still pointed correctly at Earth. It was still receiving commands. It was still transmitting science data. It was simply lying or seeming to lie about its own internal state, and for months, the team at the Jet Propulsion Laboratory had no idea why. Imagine being one of those engineers. Imagine spending your career becoming an expert in a computer system that was designed by people who, in many cases, have already passed away, using programming conventions from an era before most modern coding languages existed, with no ability to physically inspect the hardware, no ability to run diagnostics in any conventional sense, separated from the patient by a communication delay of over 22 hours each way. A question sent to Voyager 1 takes nearly a full day just to arrive. The answer takes another full day to come back. Every single test, every single hypothesis costs the better part of 2 days to check. That is the reality of trying to repair something 4 billion miles away using nothing but a signal that takes longer to arrive than most people's entire workday. Eventually, in 2023, the team traced the source of the garbled data to a single malfunctioning computer chip inside the flight data subsystem, a chip responsible for packaging the spacecraft's engineering and science data before transmission. Only about 3% of that chip's memory had failed. And yet that tiny sliver of failed memory was enough to corrupt the entire outgoing data stream, rendering 47 years of careful, precise engineering suddenly unreadable. The fix the team ultimately devised was almost poetic in its simplicity and audacity. Since they could not repair or replace the damaged chip across 4 billion miles of empty space, they rewrote the code around it, splitting the affected functions and relocating them into other parts of the spacecraft's limited working memory, essentially performing surgery on a computer that has been flying since before most of the people doing the surgery were even born. It worked. In April of 2024, Voyager 1 began returning usable data again, and when it did, something in that data hit differently. This was a machine that had, by every reasonable measure, technically died and come back, still speaking, still functioning, still out there in the dark, humming along with the interstellar wind it had been sent to measure. Now stop and sit with that, because this is where the story stops being purely technical and starts becoming something closer to unsettling. a spacecraft that experienced what engineers openly described using language typically reserved for medical emergencies, that had its data essentially scrambled into gibberish for nearly a year, was somehow still executing commands correctly the entire time. It never stopped listening. It never stopped obeying. It simply lost the ability to tell us clearly what it was hearing. There is something almost eerie, almost unsettling in a very quiet and very human way about that image. A consciousness, if you will forgive the personification, that remained functional and aware on the inside while its ability to communicate outward slowly failed. Voyager 1 was not broken in the way a machine typically breaks. It was, in a very real sense, isolated, present, working, but unable to speak clearly to the only civilization that would ever hear it. It is worth taking a moment to actually picture what solving this problem looked like from the inside, because it is easy to say a team rewrote the code and move on, and much harder to appreciate what that really involved. The engineers working on Voyager 1 today are not, for the most part, the same people who built it. Many of the original engineers have retired or passed away, and the documentation that survives is a patchwork of decades-old memos, hand-annotated schematics, and institutional memory passed down like an oral tradition inside JPL. To even begin diagnosing the 2023 chip failure, the team had to pull physical printouts of code written in an assembly language most modern programmers have never touched, cross-referencing it against systems that no longer exist anywhere except in Voyager 1 itself. Every proposed fix had to be tested first on an identical Earth-bound engineering model of the spacecraft before anyone dared risk sending it across 4 billion miles to the real thing, because a single mistake, uploaded to a computer that far away, could not simply be undone. There is no undo button when the machine you are repairing is farther from you than any object a human being has ever touched. And here's the twist that makes this entire situation even more precarious. This was not the first time, not even close. In 2020, ground controllers at the Deep Space Network briefly lost the ability to send commands to Voyager 1 entirely due to an antenna upgrade back on Earth, leaving the spacecraft essentially deaf to us, though it never stopped transmitting. In 2023, a single incorrect command accidentally sent to the wrong part of the spacecraft's computer caused Voyager 1 to point its antenna away from Earth entirely, severing communication for nearly 5 months, the longest gap in contact since the mission began. Engineers had to essentially shout into the dark using the most powerful transmitters on the planet, sending a signal called, informally, the Interstellar Shout, on the faint hope that Voyager's fault protection systems would eventually notice the silence and automatically attempt to reorient itself back toward Earth. It worked, but there was no guarantee that it would. Every single one of these incidents carried the very real possibility of permanent silence, of a signal simply stopping mid-sentence with no way to ever know exactly what happened or exactly when. Here's the part that tends to stay with people the longest, the detail that turns this from a story about old hardware into something closer to a meditation on mortality itself. Voyager 1 is dying, not through some sudden catastrophic failure, but slowly, deliberately, the way a candle burns down to nothing. Its power source is a radioisotope thermoelectric generator, essentially a controlled, slowly decaying chunk of plutonium-238 steadily converting residual heat into usable electricity as it gradually, irreversibly loses potency with each passing year. Every year, it produces roughly 4 fewer watts of power than the year before. To compensate, the team back on Earth has been doing something that would have seemed unthinkable decades ago. They have been switching off Voyager 1's instruments one by one, deliberately, permanently, sacrificing pieces of the mission to keep the whole alive just a little longer. The instrument that measured the temperature of the interstellar plasma was shut down in 2024. Others have gone dark before it. Eventually, sometime around the end of this decade, there will not be enough power left to run any science instruments at all, and not long after that, there will not be enough power left to keep the transmitter itself alive. Think about what that actually means. Right now, while you are reading this, engineers are making quiet, deliberate decisions about which of humanity's furthest reaching senses to switch off next, prioritizing which questions about the universe still get to be asked before the silence becomes permanent and total. This is not a hypothetical, distant scenario. It is happening in real time on a schedule that is being calculated and recalculated by a small team who understand better than almost anyone alive exactly how finite this connection really is. It's worth pausing here to mention that Voyager 1 is not alone out there, not entirely. Its twin, Voyager 2, launched 16 days earlier in 1977, took a different route through the solar system, swinging past Uranus and Neptune before it too, eventually crossed into interstellar space in 2018, 6 years behind its sibling. The two spacecraft crossed the heliopause at different locations and found the boundary was not a clean, uniform sphere, but something lumpier and more irregular, thinner in some directions than others, shaped less like a perfect bubble and more like a wind-battered sail pushed and dented by the pressure of the surrounding galaxy. Together, the two Voyagers have given scientists two separate data points on the true shape of the region protecting our entire solar system from the harsher radiation environment of interstellar space, a region called the heliosphere that, until these two machines crossed it, existed only as a rough sketch in a physics textbook. Neither spacecraft carries a camera capable of imaging interstellar space, and neither will ever send back a picture of what lies beyond. Everything we know about this frontier comes not from sight, but from feeling. From instruments sensitive enough to detect the faint touch of particles and magnetic fields on machinery originally built to photograph gas giants. And here's why this should matter to you personally. Beyond the engineering, beyond the plasma physics, beyond the sheer improbability of a machine surviving this long, bolted to the side of Voyager 1 is a golden record, a physical analog disc containing greetings in 55 languages, recordings of human music from Bach to Chuck Berry, the sound of a mother's first words to her newborn child, the sound of rain, of wind, of a beating human heart. It was assembled in 1977 under the direction of Carl Sagan and a small team who understood something profound. Even if Voyager 1 never encounters another living thing across its journey, even if it drifts silently through the galaxy for billions of years without a single observer, the mere act of sending it, the mere decision to try, said something true about the species that built it. We looked at the overwhelming, humbling scale of the universe, understood with total clarity how small and how brief our presence in it actually is, and we tried anyway. We reached outward, not because we expected an answer, but because reaching outward is simply what curious, hopeful creatures do. The selection of what actually went on to that golden record says almost as much about us as the record itself. Carl Sagan's committee spent months debating what a single disc, with room for roughly 90 minutes of audio and a limited number of encoded images, could possibly say about an entire species. They chose sounds of thunder, of wind, of surf breaking on a shore, alongside recordings of laughter, of a mother's kiss, of footsteps and heartbeats stitched together into what Sagan himself described as an audio essay on the sounds of Earth. They included 90 minutes of music spanning cultures and centuries, from Bach to Peruvian panpipes to Chuck Berry's Johnny B. Good, chosen deliberately to represent joy rather than conflict, creativity rather than catastrophe. They included greetings spoken in 55 languages, some of them by native speakers who had, by the time the record launched, no way of knowing whether their voice would be the only surviving trace of their language that outlasted the civilization that spoke it. And they included, etched onto the record's cover in symbolic pictograms, instructions for how to play it, a kind of universal owner's manual written for an audience that does not exist yet, may never exist, and will almost certainly not share a single frame of reference with the humans who built the device. It remains, even now, one of the strangest acts of pure hope ever attempted by our species, a bottle thrown into an ocean so vast that the odds of it ever washing up on any shore are close enough to zero to be indistinguishable from it, sent anyway. Voyager 1 is currently traveling in the general direction of the star Gliese 445, a small red dwarf it will pass within roughly 1.5 light years of in about 40,000 years. It will not stop. It will not slow down. Long after its transmitter goes silent, long after the last watt of power fades from its aging generator, long after every person who ever worked on this mission has been gone for centuries, Voyager 1 will still be moving, carrying its golden record through the dark, a message in a bottle cast into the cosmic ocean with no promise that it will ever be found, and no way for us to ever know if it is. There is a strange kind of comfort hidden inside all of this, if you look for it. Every discipline of science that Voyager 1 has quietly rewritten, from the density of interstellar plasma to the true shape of the heliosphere, was only rewritten because something we built kept going long after anyone had a right to expect it to. The engineers who patched a 47-year-old computer using code written before some of them were born were not simply performing routine maintenance. They were extending a promise made in 1977, a promise that this small, aging machine would keep listening for as long as it possibly could, and that someone back home would keep listening back. That promise has now outlasted careers, outlasted entire scientific consensus about what the outer solar system even looks like, and it is about to outlast the mission itself, because listening back is a choice that has to be renewed deliberately generation after generation by people willing to decode a whisper from a snowflake's worth of power arriving across billions of miles of silence. Here is the detail that tends to stick with people the most, the one worth sitting with as this story closes. Somewhere between now and roughly 2030, Voyager 1 will fall permanently silent. We do not know the exact date. We may not even know it is happening in real time, since a final failure could easily look identical from Earth to just another temporary glitch until the days of silence stretch into weeks and the weeks stretch into certainty. When that happens, it will not be dramatic. There will be no explosion, no visible event, no clean and cinematic ending. There will simply one day be no signal where a signal used to be, and humanity's furthest reaching hand, the one object we have ever built that touched the space between stars, will finally quietly stop speaking. But it will not stop existing. It will not stop moving. It will simply continue alone, carrying the sound of a human heartbeat and the memory of a species that once looked up into an incomprehensibly vast darkness and decided, against every reasonable argument for staying quiet and staying small, to say something anyway. Somewhere out past the edge of everything familiar, a machine we built before most of us were even born is still listening to the hum of interstellar space, still obeying commands sent from a planet it left before some of the people reading this were alive, and it will keep going, silent or not, for longer than any of us will ever be here to witness. If that does not make you want to step outside tonight and simply look up for a while, it is genuinely hard to know what will. Somewhere up there, past every star you can actually see with your own eyes, a small machine we built and then let go is still going, still listening, still doing its job. If this is the kind of story you want more of, the kind that makes the impossibly vast feel personal and close, stick around because there's a lot more out there, quietly waiting, worth sitting with.